Every total solar eclipse on Earth is only possible because of one mathematical coincidence, so precise that astronomers still can't explain it. The moon is exactly the right size, at exactly the right distance, to fit perfectly over the sun. Not approximately, perfectly. And that's just the beginning of what we don't understand about it. In this explainer, we're going to dive deep into a true cosmic paradox. Because when you really look at the moon, when you really look at the hard scientific data we have on it, that perfect eclipse is just the first thread in a very unsettling mystery. So let's break down that math. The sun is roughly 400 times larger in physical diameter than the moon. But simultaneously, the sun just happens to be exactly 400 times farther away from Earth than the moon is. Because these two ratios mirror each other so perfectly, both bodies take up the exact same angular diameter in our sky, roughly half a degree. Think about the sheer, staggering improbability of that for a second. Out of all the vast, violent chaos in the solar system, we have a moon stationed at the exact mathematical precipice required to flawlessly mask our star. And the eerie precision of this alignment hasn't just bothered modern astrophysicists. Even Isaac Asimov, the legendary science fiction visionary and biochemist, pointed out this unsettling reality way back in 1965. He realized that of all the planets, Earth is the only one blessed with this exact geometry. There's literally no physical law demanding the moon be this size or sit at this exact distance. It just does. Okay, let's move on to the next anomaly. And this one is about the fact that the moon permanently hides half of itself from us. We call this synchronous rotation. The moon rotates on its axis at the exact angular velocity required to perfectly match its 27.3-day orbital period around Earth. Now, mainstream planetary mechanics explains this as a natural outcome of tidal locking, the idea that Earth's massive gravity acted like a brake on the moon's original, faster rotation. But just sit with the reality of that result for a moment. We have an object suspended in our sky, perfectly synchronized to ensure its far side remains forever concealed from our eyes. But as mysterious as the surface is, it's actually nothing compared to what's inside. To figure out what the moon was made of, NASA's Apollo mission set up a network of passive seismometers between 1969 and 1977. But to calibrate those instruments, they needed to create controlled seismic events. So, what did they do? They deliberately crashed heavy Apollo hardware straight into the lunar surface. In November of 1969, they sent a 2.5-ton lunar module ascent stage hurtling into the ground at 6,000 kilometers per hour. A few months later, they crashed an even more massive Saturn V third stage. And what those seismometers recorded literally sent shockwaves through the scientific community. The crucial thing here is how the moon reacted to those massive impacts. To put it in perspective, think about a standard earthquake. On Earth, a seismic signal decays really rapidly. Because we have water inside our rocks and a molten interior, all that seismic energy gets absorbed quickly, usually returning to baseline in just 1 to 2 minutes. But the moon, when NASA crashed that hardware, the signal didn't just die out. It built up slowly, peaked minutes later, and then reverberated for nearly an hour. The moon is cold, dry, and doesn't absorb energy the same way. As the famous phrase from the data goes, the moon rang like a bell. This diffuse, endless swelling of energy was so profoundly unnatural compared to Earth that it actually sparked those intense myths that the moon might be completely hollow. And I'm telling you, the deeper we look, the stranger the physics get. Let's talk about its gravity. Starting around 1968, satellites orbiting low over the moon's surface were inexplicably yanked off course. They were literally dipping toward the surface before pulling back up. The cause turned out to be localized, massive gravity anomalies called mascons hiding beneath the lunar craters. Now, normally, an asteroid impact blasts away mass, which leaves a crater and a negative gravity signature. But when NASA's Grail mission mapped this in high resolution, these impact basins displayed positive, bullseye gravity signatures. We're talking concentric rings of alternating high and low gravity that completely contradict standard cratering models. The moon's mass is distributed in a way that actively fights our basic understanding of orbital physics. Which brings us to the ultimate question. Where did this object actually come from? For decades, mainstream science has relied on the giant impact hypothesis. The standard model argues that roughly 4.5 billion years ago, a Mars-sized protoplanet named Theia smashed into the early Earth. This catastrophic collision vaporized silicate debris, blasted it into a disk around our planet, and then it quickly clumped together to form the moon. On paper, it's a neat, elegant theory. It cleanly explains the angular momentum of the Earth-Moon system and why the moon has a relatively small iron core. But here is where the science severely breaks down. Hard, undeniable geochemical data points to a massive contradiction. See, in the early solar system, every single planetary body formed with a distinct, highly unique isotopic fingerprint. If Theia hit Earth, the moon should be made mostly of Theia's distinct material. But high-precision mass spectrometry of the Apollo lunar samples reveals what scientists call an isotopic crisis. The Earth and the moon have virtually identical isotopic ratios for elements like oxygen, titanium, and tungsten. Geochemically speaking, this is practically impossible under the canonical impact model. The odds of an alien impactor having the exact same isotopic signature as the Earth are vanishingly small. Because of this, astrophysicists are currently backed into a corner. Every time they adjust their models to fix one problem, they break something else. The canonical model explains the physics, sure, but it fails the isotopic data entirely and falsely predicts a completely dry moon, which we now know is wrong since the moon has trapped indigenous water. Then you have the equilibration model, which tries to mix the vapor to match the isotopes, but that requires impossibly narrow thermal conditions. The high-energy synestia model, it's incredibly difficult to even simulate dynamically. And the velocity contrast model depends entirely on completely unknown pre-impact states. Every single variant of the origin theory eventually shatters against the hard physical data. So let's review. We have a moon that perfectly eclipses our sun due to an inexplicable mathematical ratio. It permanently hides its face from us. It rings like a bell for an hour when struck. Its gravity maps completely defy standard physics, and according to our own chemical analyses, it couldn't have formed the way we think it did. The deeper we analyze its geometry, its seismic echoes, and its very atomic structure, the less sense it makes as a random byproduct of a cosmic chaotic cosmos. We are orbiting a paradox, which leaves us with a quiet, deeply unsettling reality. If it wasn't natural, what was it?